This is an example of a cumulative frequency plot. What you have on the y-axis is cumulative frequency. It always goes up to 1, or 1 is the highest. That represents 100%. And then your x-axis is whatever your variable is. What we're looking at here is age of the U.S. population. And we actually have two cumulative frequency plots on this plane, one for 1860 and one for 1980. And our question is, how do the medians and interquartile ranges compare? If you understand percentile, you can work with this. So median is what percentile? 50th percentile. So what you do is you go to 0.5 on the y-axis, you draw a line over, and then where it connects, you look down. So the median age in 1860 was only 20 years old. And now let's compare that with 1980. It looks like it was 32 years. So 1860, median was 20. And in 1980, it was 32. So half the country was younger than 20, half the country was older than 20 in 1860. In 1980, half the country was younger than 32, and half the country was older than 32. First quartile, what's the percentile? 25th, yep. So you do a similar operation. Here's 0.25. And it looks like it's there. So it looks like about 9 years of age in 1860. A quarter of the country was 9 or younger. Very young country. And then for 1980, let's keep going. It's here. "12, 14, 16. And then, since we want to find the interquartile range, we'll need Q3. So I think you know that that is the 75th percentile. Looks like the halfway part there. So 32, 34 looks like 35 in 1860. And then for 1980, people are living a lot longer, so we have to go further out. Looks like there. Okay, it looks like 50 years of age. And then I think you know how to find IQR by now. Looks like 26 here and 34 here. Okay? That's pretty much it. So again, if you know percentiles, you can work with the cumulative frequency plot. You just find the percentile on the left-hand side, draw a line over, draw a line down. That's the value. You can use that to find median, quartiles, interquartile range. Okay? Conceptually, it can be helpful to understand how a histogram compares to a cumulative frequency plot. So if you have a histogram like this, where you have skew to the right, if you've taken calculus, the cumulative frequency is the integral of the histogram. So if you're going from left to right, in this plot, you're filling up your gas tank, so to speak, very quickly in the beginning. So if you look at the corresponding cumulative frequency plot, it has the steepest slope in the beginning. You can think of 1.0 as being a full gas tank. So it's like, how long does it take for you to fill your gas tank? We're filling very quickly, and then once we get past 1.75 or so, the fill rate declines rapidly. So if you look here, we're about 1.75, then it's a very, very slow fill. It takes us a very long time to get to a full tank. A symmetric histogram like this, slow fill rate in the beginning, as you can see here, and then it really picks up, so you can see the steeper slope here, and then after about maybe 2 1/4, dies back down. You can see that slope changing there. And then lastly, for a distribution that's skewed to the left, because your tail is on the left, it's going to take you a really long time to fill up, at least in the beginning, to fill the tank up to some minimal amount. And you can see that going on here. Really, really slow, accumulating the frequency. And then after 2, it starts to pick up. Okay? So that might be helpful. Any questions on the cumulative frequency plot?